Okay, for the graph of secant, oh, and let me see if my pen decided, oh, my pen's working again. It stopped working first period. Anyway, when you go to graph secant, you want to remember that secant is 1 divided by which trig function? Everybody, which trig function? Secant is 1 over cosine. So if I remember what cosine looks like, it goes through those points. And I'm going to add in this point over here. And where cosine crosses the x-axis, its reciprocal function has vertical asymptotes. And where cosine is equal to 1, that is where the graphs share a point. And where it is -1, the graphs share a point. And what is your last name? Daly. Daly. You can't sit? There you go. You can just lean. Okay, so we need to highlight from x equals 0 to pi over 2 gives us this section, and every single graph uses 0 to pi over 2. Then I want you to see that if we cross over the asymptote and go to pi, can you see that what is highlighted there does pass the horizontal line test? That with the yellow highlights, there is no horizontal line. Let me actually do this. I can draw a horizontal line. Well, try to draw a horizontal line. There we go. Do you see that as I move this line around, it only crosses the highlighted section once at a time? So that section passes the horizontal line test. But if I were to take this section from -pi over 2 to 0, that would not pass. There we go. That would not pass the horizontal line test if I use -pi over 2 to +pi over 2. So the answers are, for part C, if you continue from pi over 2 to pi, yes, it does pass the horizontal line test, but if you go backward, it does not. Now, what that gives us is from 0 to pi, and 0 is included in the domain of this inverse trig function. However, do you see the annoyance of we've got an asymptote in the middle? We unfortunately have to deal with that. So what I want you to do is, all you need to get from this is between 0 and pi is the section that we use for secant. Technically, we don't include pi over 2. So we have to add in that extra bit to express that that is the domain for inverse secant. And then again, the notation. Now I want to turn over to the classwork answers for the last one. I'll give you a moment to write that down. And then over to the classwork answers with the very last one. And this one has the same situation of I have to use a domain where an asymptote cuts it in the middle. And it's a bit annoying to have to do that. So if I go forward, I will not pass the horizontal line test, but if I go from -pi over 2 to 0 with the 0 to pi over 2, I do pass the horizontal line test. And the way I have this written is just to keep it more general. Technically, though, while I am working with the interval from negative pi over 2 to pi over 2, technically 0 is not included. In this class, you're not going to be responsible for recognizing the officially correct domain. All you're going to want to do is recognize who gets the negative to positive pi over 2 and who gets the 0 to pi. And then the summary, along with the notation for inverse cosecant. The summary is when you are working with inverse sine, inverse tangent, or inverse cosecant, the angle range you are working with is from negative pi over 2 to positive pi over 2. So just to present it, you've got negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6, and then what we're familiar with, 0, pi over 6, pi over 4, pi over 3, and pi over 2. Know that if you use the inverse buttons on a calculator, you can, for these three functions, only get answers within these angle ranges. It will only give you one answer. For inverse cosine, inverse cotangent, and inverse secant, the calculator will only give you answers from 0 to pi. And you don't have to know the specifics on the domain. You just want to recognize who gets the right side and who gets the top half. And I'm going to give you some strange study ways to remember this that I've heard over the years. For this is a spilled bowl of cocoa seek. You know, there's Cocoa Puffs, but then there's cocoa seek. Don't spill your cocoa seek. For some people, they actually remember it that way and they're all good. Then over here, this is going to sound really weird, but it's what I didn't make this up. I feel like I need to say that just to save face on this. So can you see a climbing upwardness with this? Who climbs up chimneys? Santa Claus. Okay, yeah, it's not severely helpful, but for some people they have found it helpful, so I'll point that out. Let me say this, though. Sine, tangent, and secant are the ones that don't have cos. So a way that you can remember this is don't worry about secant and cosecant. Those are reciprocal functions. Focus on remembering that you've got a sine tangent pair and a cosine cotangent pair. If you're working with inverse sine or inverse tangent, you are dealing with the negative pi over 2 to positive pi over 2 angle range. If you are working with inverse cosine or inverse cotangent, you are working with 0 to pi angle range. And then just remember that reciprocals have to remain with the same domain. So sine and its reciprocal, cosine and its reciprocal are banded together. And now let's do something about this. Oops, those are answers. Here we go. Okay, you need to find you're going to get out a calculator, by the way. You need a calculator. And I'm going to teach you how to work with if you are using a scientific calculator. Because I will tell you that there are some benefits of a graphing calculator, but I'm not going to discuss them. If you can see how you can use a graphing calculator to your benefit, use it. But I'm going to focus on how to use the scientific calculator in finding these. So we're wanting to look for two positive angles between 0 and 2 pi that solve these equations. Now, if I go back to when we were using the unit circle, we would solve equations like if sine theta equals 1/2, what are my two angles between 0 and 2 pi? When we were using the unit circle, we knew the exact angles that go with this. We were using that when the y value is 1/2, that takes us to these two spots on the unit circle, and those are pi over 6 and 5 pi over 6, and you had your answers to solve that equation. Now, with the equation sine theta equals 2/3, I want you to be aware that just like before, drawing a horizontal line where y is equal to 1/2 allowed us to see the angles that would give us 1/2 when we asked what is the sine of that angle. If I draw a horizontal line at 2/3, it's not one of our special numbers. Well, that was probably let me try again. 2/3 is about maybe there-ish. So understanding that this is y equals 1, 2/3 is here, and that takes us to two specific angles between 0 and 2 pi. And just to make sure you're clear, those two angles are whatever angle it takes, so that the initial side being here at 0 and the terminal side goes through a point on that unit circle where the y coordinate is 2/3. Then there's a second angle where its terminal side stops here. And from the initial side to that terminal side, I get a second angle whose sine is equal to 2/3. And there are two angles between 0 and 2 pi that have a sine that is equal to 2/3. Now, since 2/3 isn't one of the special unit circle numbers, you're going to turn to your calculator. When you use the inverse sine feature, so you're going to look for a button on your calculator that shows sine and a little -1 symbol with it. You're going to find the inverse sine of 2/3. Your calculator is going to give you an answer, but you need to understand that it will only give you one answer, and it will only give you an answer within the angle range of -pi/2 to +pi/2. So it's going to give you this angle right here. That's the one we're going to get an answer to from our calculator. So everybody, calculator, what is the inverse sine of 2/3? I'm going to grab Desmos. And if you use Desmos, then I can go over to inverse sine and type in 2/3. And I get an answer 0.73. 0.73 is one of my answers, but there are two angles between 0 and 2 pi. And for some of you, I want you, if you're thinking you want to go further in math, I want you to step back and take a look at the symmetry there. 0.73 is this angle right here. Do you see that that's the same angle as this measurement? Right here is pi radians. If I do pi minus 0.73, that will take me to this angle. I want you to first see the visual nature of it, but you're going to be allowed to just use a formula. Every time sine shows up, your calculator is only going to give you one number for its inverse function. You can find the second angle if you do pi minus the answer that you just got from your calculator. This is the formula that will always work when you're dealing with inverse sine. Your calculator gives you an answer. This will give you the second angle that your calculator is not able to find. But I'm not talking about a graphing calculator, because a graphing calculator will allow you to do a lot more. But if you're dealing with a scientific calculator, you will only get one answer. And you need to be aware that there are always almost always two answers. Okay, so that's sine. And then I'm going to move over to cosine and just make sure to at least hit these three. So with cosine, do you remember in the past with the unit circle that when you were working with cosine, you were looking at an x-coordinate? So if you had in the past, say, cosine theta is equal to, let's go with root 3 over 2. When you had that, you were looking at x-coordinate 1 over 2, root 2 over 2, root 3 over 2, and that took you to the angles pi over 6 and 11 pi over 6. That was, without a calculator, what you're expected to be able to solve. With a calculator, you can solve a lot more, but you've got to be aware of what your calculator will give you and will not give you. When it comes to cosine, your calculator is only going to allow you, it will only bring out one answer, and that one answer will be somewhere between 0 and pi. So if you were to push the inverse cosine button for root and then put root 3 over 2 in, you would only get out the answer pi over 6, but in decimal form, because it's not going to write it all nice. So when I come over here to the cosine of theta being equal to 0.37, what I want you to see is along the x-axis, I have 0, and I was aware of before 1 over 2, root 2 over 2, root 3 over 2, and 1. Now, 0.37 is, say, about here-ish, maybe? I'm just trying to guess the plot there. So it's not one of the unit circle spots where I know the exact angle measure. But I want you to see with this picture that cosine representing x means if you were to draw a vertical line at that x coordinate of 0.37, it's going to hit the unit circle in two places. And what's that? That is telling me is starting from angle 0 with a terminal side at whatever angle this solution is, this spot is going to give me this angle. This spot is coming from this angle, which my calculator is not going to give me. Now, with the calculator, you're going to first use your inverse cosine button and put in 0.37 and see what it gives you. So I'm going over to Desmos and inverse cosine and 0.37. And I get that the angle measured in radians is 1.19. .19 is then this angle. And remember that with cosine, my answer will only be something between 0 and pi. And so this is the only answer I'm able to get out. However, for most of the problems, it's a very small rarity, and it's only when you're using the unit circle anyway. But anyway, blah, blah, blah. There's always a point that, or an angle that, okay, use your words. There's always a second angle position that goes with cosine of what angle is equal to this number. When you use the inverse button on a calculator, it's only going to give you one spot. It will not give you the second spot. And so you want to be aware of how to find it. And if you look at this picture right here, and you think about the symmetry involved, then what you want to see is if you start at 2 pi and you subtract this angle, that will give you this angle. Now, ultimately, you can just use this formula, but I want you to see that you don't have to memorize a formula if you understand the symmetry, which is valuable for those of you who are going to need to use trig later on. So I'm going to find my second angle through that subtraction. This is what I'm going to use for inverse cosine. Okay, I'm going to find these two numbers because I just realized I didn't actually find that one. So for the value I got from sine, pi minus that number, pi minus, and then I can just go ahead and type in the 0.73. It doesn't have to be accurate. And I'm getting 2.41. So for problem number 1, the two angles between 0 and 2 pi are these two. If you needed to, from there, you can add 2 pi or subtract 2 pi any number of times from either of those two numbers and get every single solution you would ever need. But I should add that the graphing calculator, darn you, too little time. The graphing calculator will actually find you all these answers much faster. But we're out of time. So I will make sure to post what you need to get done today because, well, it looks like we're going to have to keep working on this tomorrow. Thank you, Exhibition Day. But yes, thank you, Exhibition Day, because it's fun. But yeah. Anyway, I didn't get your name. Okay. I just need to make sure to mark you with attendance.
In the chat, I was like, where's the pasta?
Okay, let me, I've got it in the recording.